Hi, I'm Paul Heaney, Editorial Director for Design World, here with another installment from the Fluid Power Handbook. Today's installment is on accumulators. Accumulators are pressure vessels that store hydraulic energy and deliver that energy back to the system on demand. This is analogous to the way a car battery stores energy. In hydropneumatic accumulators, compressible gas, nitrogen, is used to keep stored fluid pressurized. Hydropneumatic accumulators are used extensively in the global fluid power industry. There are different designs to separate gas from fluid. Bladder accumulators use a flexible closed bladder. Diaphragm accumulators use a flexible open diaphragm or membrane. Piston accumulators use a movable piston with a system of seals. Float accumulators allow a buoyant valve to open and close the accumulator when necessary. For seamless high-pressure bladder accumulators, chrome moly steel has been used extensively for more than 40 years. This material has a high tensile strength equivalent to AISI 4130. This material lends itself well to forming and machining and has a burst pressure more than 350% of design, or a 3.5 to 1 safety factor. Various applied coatings can enhance resistance to rust, corrosion, and abrasion. Most notably is the internal coating of phenolic resins. This material is an excellent choice to resist many common process fluids and has shown excellent chemical resistance. It's easily applied, and for bladder accumulators, aids in applications where lubrication from the working fluid is poor. Because of the smooth surface, it helps prevent the bladder from adhering to the internal wall surface during operation. Electroless nickel plating is also very popular. This coating is applied approximately 2 mm thick internally and externally. Electroless nickel has been proven to be a very durable material, cost-effective, and has been shown to be a viable alternative in many applications to the significantly more costly stainless steels, while at the same time maintaining the strength integrity of the carbon steel. This variation, as with the phenolic coated variation, can be combined with 316 stainless steel connections. These connections include the fluid and gas ends of the accumulator, along with all of the internal component parts. The most common and most widely used of all hydraulic accumulators are for the fluid power market. These accumulators are designed typically to operate up to 6,000 psi. Both the piston and the bladder manufacturers provide the fluid power industry with variations from 1.5 cubic inches of displacement up to 120 gallons of capacity. These are the most common accumulators selected by OEM manufacturers for injection molding machines, rubber presses, die casting machines, machine tools, presses, and a variety of automated machines and process lines with extensive use in the land-based and offshore oil industry. Smaller accumulators, known as the diaphragm type, are used for mostly pulsation dampening, where flow rates are relatively low, on line sizes under 1 inch in diameter. These accumulators are usually non-repairable and must be disposed of when failure occurs. Repairable diaphragm accumulators are now common with some manufacturers. The diaphragm accumulator is a relatively low-cost device, rated up to 3,000 psi, but can be used on low-pressure applications as well. They're very reliable products, and with proper pre-charge maintenance, will maintain their reliability. Properly sizing the accumulator is the first element of reliability. One must size the accumulator according to the application, taking into consideration flow rate, maximum operating temperature, maximum and minimum pressures, and of course fluid compatibility. Boyle's law of gases is the primary formula for sizing. Specific formulas, depending on the application, expand from the primary formula that we're going to talk about in just a moment. Compression of gas, temperature, and cycle times are factored in the expanded formulas. Now, normally you have P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. After correctly sizing the accumulator for its particular application, materials must be properly chosen for compatibility. Proper elastomers are chosen depending on the fluid and the operating temperatures. From there, connection sizes can be chosen with a host of options. For the 500 psi designed bladder accumulators, normally the standard ANSI 4-bolt flanges are the standard, based on commercial piping connections from 150 pounds to 600 pounds. For the 500 psi designed bladder accumulators, normally the standard ANSI 4-bolt flanges are the standard, based on commercial piping applications from 100 to 600. For high pressure accumulators, over 500 psi designs, piston or bladder, the choices are female NPT, SAE, BSP, or SAE split flange connections. For Design World, I'm Paul Haney.